An open top box with a square base is to be constructed by taking a 48 by 48 square piece of material, cutting an X by X square section from each corner and folding the sides up. Write a function in terms of X to compute the volume of the box. For what number X is the value of the volume maximized? Solution here. Notice the goal is maximize volume. What volume? Well, the volume of a box that will be formed once we fold the flaps, right? Well, it looks more or less like this. And what is important here is to notice that once you construct the box, the height of the box, since we're gonna fold this up, should be equal to X, right? X. Also notice that the width should be 48 minus X here, minus X here. So 48 minus twice X, right? Similarly, the length, 48 minus X here, 48 minus twice X. Okay, now the volume is equal to the width times the length times the height, right? So our volume will be equal to the width, 48 minus twice X, times the length, 48 minus twice X, times the height, X. Let's FOIL this out. V should be equal to 48 times 48. That you can get with your scientific calculator. I'm using here Desmos scientific calculator. 48 times 48 is 2,304. 2,304. (48 times negative 2x is minus 96x. Minus 96x again. Minus 2x times minus 2x plus 4x squared, right? And this is just what we got out of FOILing these two out. Notice there is still an x there. Simplifying, this is going to be 2,304 minus 96 minus 96 is 192 negative x plus 4x squared times x. Finally, the volume will be x times 4x squared, 4x cubed, x times negative 192x, be negative 192x squared. And finally, this time this should be plus 2,304x, right? Now, remember, in order to maximize the volume, we have to set the derivative of v with respect to x equal to 0, right? So we can catch the critical value. So derivative of this guy is equal to 3 coming down, multiplying 4 is 12x squared minus 2 multiplying 192 will be 384x plus 2,304, right? This is the derivative. That should be equal to 0. Now we have to solve this quadratic equation. And I'm going to solve it in general, right? I know you may say we could divide both sides of the equation by 12. That can be done, right? But imagine the division produces here decimals. We don't want to carry over error, right? We want to do it as accurate as possible. So we're going to use the quadratic formula, which is this. With A equal 12, B equal negative 384, and C equal 2,304, right? Again, we're putting ourselves worst case scenario, right? Suppose the numbers are not friendly. This is what you have to do. All right, now for the computational part, we're gonna use our scientific calculator, right? We need a fraction, so I'm gonna choose this fraction. And then minus B should be what? Minus negative 384. I'm going to start with plus, then I will calculate the one minus plus a square root of b squared. B squared is minus 384 squared minus 4ac. 4 times a, 12. C is 2,304. Over twice a, twice 12, right? Look, I got 24 for the first solution, right? That's when I use plus. When I use minus, I get 8. So two possible solutions, 24 and 8, right? Let's write them down. X 24 or X equal 8. But which one is the one? Well, in order to figure that out, we can evaluate X into our volume function, right? Noticing that X should be greater or equal than 0. 0 is smallest value for X, and less than or equal than, notice this is 48. What's the biggest value X could be? Well, half of 48, right? Half of 48, right? Half of 48 here, you will be left with nothing there, right? For the other dimension. So half of 48 is 24. All right, so we have to evaluate X at endpoint 0, critical point 8, endpoint 24, right? And see which leads to the highest volume. Clearly, if you evaluate your volume function, which is here, at X equals 0, this should be 0, this should be 0, this should be 0. So the volume should be 0, right? If you evaluate your volume function at 8, let's see what happens. Let's do it in our calculator. 4 times 8 cubed minus 192, 8 squared, plus 2,304, 8. We get 8,192, right? 8,192. Okay, and notice that if you evaluate this at 24, since I explained to you that if you take 24 from each corner, there is not going to be material left to form the box. So this should be 0, right? As you can see, 0. All right, so the one we take then is the one that makes sense, is this, right? $8,192. 8,192. And this should be in here, max, because this is 0, right? So clearly this is where the maximum happens. So X has to be equal to 8 in order to maximize the volume, right? So for x equal 8, volume is maximized. And here you have the function that represents your volume, right?